Hello students, welcome to SANKALP CET classes. So today we will be discussing the topic three-dimensional geometry. So three-dimensional geometry, it is comprising of the portion covered in both the years PU1 as well as PU2. So first we will be discussing some basics of first year, and then we will concentrate on the second year part. Definitions and results. So distance formula, distance between 2 points P and Q. So if P and Q are 2 points P x1 y1 z1 and Q x2 y2 z2, then the distance between P and Q is given by the formula PQ equal to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Next, if one of the point is origin, then distance of any point x1 y1 z1 from the origin is given by the root of x1 square plus y1 square plus z1 square. So distance formula for three-dimensional space, for points in three-dimensional space. Next we have section formula. So the coordinates of the point which divides the line joining the points P and Q in the ratio L is to M internally. So suppose if PQ is a line, and R divides it in the ratio M is to N, then the coordinates of the point R, are given by Lx2 plus Mx1, Ly2 plus My1 divided by L plus M, Lz2 plus Mz1 divided by L plus M. So here they have considered the ratio as L is to M. Okay, L is to M. The same formula we are using for external division. So when we are using the formula for external division, the positive sign gets replaced with the negative signs. Next, the coordinates of the midpoint of the line joining the points P x1 y1 z1 and Q x2 y2 z2 are. So when the ratio is 1:1, or when R is the midpoint, okay, R is the midpoint of P and Q. If it is the midpoint of the P and Q, then the coordinates are given by x1 plus x2 upon 2, y1 plus y2 upon 2, and z1 plus z2 upon 2. Next, the centroid G of the triangle ABC, where A x1 y1 z1 and B x2 y2 z2 and C x3 y3 z3 is given by G is equal to x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3, and z1 plus z2 plus z3 upon 3. So the point of intersection of the three medians of a triangle, okay, gives us the centroid. Okay, so median is a line segment which joins the vertex of a triangle, with, see, the vertex A, we are joining it to the midpoint of opposite side. So here AD will be median. Same way we have three medians from all the three vertices, and the point of intersection of all the three medians gives the centroid of the triangle. Next, we have the centroid of a tetrahedron. So tetrahedron, it is having four vertices. So the centroid in this case is given by x1 plus x2 plus x3 plus x4 upon 4, y1 plus y2 plus y3 plus y4 upon 4, and z1 plus z2 plus z3 plus z4 divided by 4. Okay. So next part. So the next concept is the direction cosines and direction ratios of a given vector. So if alpha, beta, gamma are the angles made by the vector A with the positive direction of x, y, and z axis, then cos alpha, cos beta, and cos gamma are called as the direction cosines of vector A, and usually they are denoted by L, M, and N. So L is equal to cos alpha, m is equal to cos beta, and n is equal to cos gamma. Next, three real numbers a, b, c, which are proportional to the direction cosines L, M, N of a vector are called direction ratios of the vector, and they will be proportional to the direction cosines. So we have the relation L upon A equal to M upon B equal to N upon C. Next, results related to direction cosines. If R is equal to x1 I cap, y1 j cap, z1 k cap is a vector along AB, then x1, y1, z1 are the direction ratios of the line AB. So if R is the vector along R, then the component I, j, k of R are the direction cosines of R. Okay, they are the direction cosines of R. So here A, B, C are the direction ratios, and the direction cosines are given by the formula A upon root of A square plus B square plus C square, B upon root of A square plus B square plus C square, and C upon root of A square plus B square plus C square. So the direction cosines of the line equally inclined to the coordinate axis are if the line L is equally inclined, if it is equally inclined, then we get the direction cosines LMN as 1 upon root 3, plus or minus 1 upon root 3 and 1 upon root 3. Next, the sum of the squares of all the three direction cosines is equal to 1. L square plus M square plus N square is equal to 1. And when we substitute the value of L, M, and N in the formula, we get cos square alpha, cos square beta, cos square gamma equal to 1. On replacing cos in terms of sine, we get sine square alpha plus sine square beta plus sine square gamma is equal to 2. Next, if P, X, Y, Z is a point and OP is the direction vector magnitude of the vector OP, then direction cosines of OP are given by L equal to X upon R, Y upon R, and Z upon R. So we can also calculate the coordinates by substituting X is equal to LR, Y equal to MR, and Z equal to NR. So this is for one single point, whereas one point is origin. Next, when we have 2 points Px1, y1, z1 and Qx2, y2, z2, then the direction ratios are given by x2 minus x1, y2 minus y1, z2 minus z1, and its direction cosines are x2 minus x1 upon mod of pq, y2 minus y1 upon mod of pq, and z2 minus z1 upon mod of pq. Next, the direction cosines are x-axis, the direction cosines will be 1, 0, 0. Y-axis direction cosines will be 0, 1, 1, and z-axis 0, 0, 1. So if the line is along x-axis, then it will be 1, 0, 0. Similarly, y and z-axis. Next, angle between the lines. So if L1, M1, N1 and L2, M2, N2 are the direction cosines of two lines, then the angle theta between the lines is given by cos theta is equal to L1, L2 plus M1, M2 and N1, N2. So if we replace the values of L1, L2, M1, M2 and N1, N2, we get A1, B1, C1, A2, B2, C2. So if we replace it by direction ratios, if the direction cosines are replaced by the direction ratios, then cos theta will be equal to A1 A2 plus B1 B2 plus C1 C2 divided by root of A1 square B1 square C1 square into root of A2 square plus B2 square plus C2 square. Okay, so next point, after understanding direction cosines and direction ratios, the next point is equation of planes. So first degree equation ax plus by plus cz plus d equal to 0 in x, y, z always represents a plane. So here a, b, c are the direction ratios of the normal drawn to ax plus by plus cz plus d equal to 0. Second point, the equation of the plane in normal form is given by r dot n cap is equal to p, where p is the length of the normal from the origin, onto the plane, and n cap is the unit vector along the normal. Next, Cartesian form. So for the same vector, if we replace n with Lx with L I cap M j cap and n k cap, then we get the Cartesian form as Lx plus My plus Nz, Lx plus My plus Nz. Here we have Z and Z. Nz is equal to P, where again P is the length of the normal from the origin. Next, third equation, the equation of the plane passing through a point whose position vector is A and perpendicular to the vector n is given by r minus a dot n equal to 0. So if we replace A with the coordinates x1, y1, z1 and n with its direction ratios, then we get A into x minus x1 plus B into y minus y1 plus C into z minus z1 equal to 0. Next, equation of the plane passing through three points, three non-collinear points, okay, whose position vectors are A, B, and C is given by r minus a, comma r minus b, and r minus c equal to 0. The same equation can be written in Cartesian form as x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. So here we are replacing A with x1, y1, z1, we are getting the first row. We are replacing B with x2, y2, z2, we are getting the second row, and C we are replacing it by x3, y3, and z3. x3, y3, and z. So the next form of the plane, intercept form. So equation of the plane making intercepts A, B, C on coordinate axis is given by x upon A plus y upon P plus z upon C is equal to 1. Next, equation of the plane through 2 points whose position vector are A and B and parallel to the vector C is given by r minus A minus B, C equal to 0. And in Cartesian form, we have x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, a, b, c is equal to 0. A, b, c is equal to 0. Next, some results associated with planes. So if 4 points to be coplanar, so 4 points are said to be coplanar. Okay, if they satisfy the condition x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1, x4 minus x1, y4 minus y1, z4 minus z1 is equal to 0. Next, the length of the perpendicular from the origin to the plane ax plus by plus cz plus d equal to 0 is given by mod of root of a square d upon root of a square plus b square plus c square. Okay, it is given by d upon square root of a square plus b square plus c square. Next, length of the perpendicular from the point x1, y1, z1 onto the plane ax plus by plus cz plus d equal to 0 is mod of ax1 plus by1 plus c1z plus d divided by root of a square plus b square plus c square. So here in the plane we are replacing x, y, z by the coordinates of the point. So when we replace the x, y, z values with the coordinates of the point and substitute in the equation, we get the distance between the point and the plane. Okay, distance between the point and the plane. Next, equation of the plane parallel to the given plane is of the form. So if ax plus by plus cz plus d equal to 0 is the first plane, and then only the constant, that is the d value, will get replaced by k. Rest of all the coefficients will be same. Next, equation of the plane through the intersection of two planes. So if a1x plus b1y plus c1z plus d1 equal to 0 and a2x plus b2y plus c2z plus d2 equal to 0 are two planes, then the equation of the new plane which is passing through the intersection of these two planes is given by a1x plus b1y plus c1z plus d1 plus lambda into a2x b2y plus c2z plus d2 equal to 0. The next equation is for angle between two planes. So angle between two planes is nothing but the angle between their normals. So cos theta is equal to a1a2 plus b1b2 plus c1c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. So the planes are perpendicular if cos 90. So cos 90 is equal to 0. So we get the condition a1 a2 plus b1 b2 plus c1 c2 equal to 0. So if the two planes are parallel, they satisfy a1 upon a2, b1 upon b2, and c1 upon c2. Next, the next equation is for the equation for the distance between parallel lines. So distance between two parallel lines is given by mod of d1 minus d2 divided by root of a square plus b square plus c square. Now equation of xy plane is z equal to 0, yz plane is x is equal to 0, and equation of xz plane is y equal to 0. So equation of a plane parallel to xy plane is z equal to k. Similarly, yz plane, it will be x is equal to a, and xz plane is y equal to a. Okay. And next, the plane perpendicular to xy plane is of the form, okay. So here z coordinate will be missing. So we get ax plus by plus d equal to 0. Similarly, for zx plane, we get ax plus cz plus d equal to 0. So these were few points regarding planes. Next, we will discuss few points regarding equation of lines. Next, equation of lines. So the first equation of the line is the line passing through a given point and whose position vector is A, and parallel to a given vector B is R is equal to A plus lambda B. R is equal to A plus lambda B, where A is the position vector of the point and B is the parallel vector. So when we substitute the coordinates of A as x1, y1, z1, and B the direction cosines of the parallel vector, then we get the equation in Cartesian form, which is x minus x1 upon L, y minus y1 upon M, and z minus z1 upon N. If we substitute the direction ratios, L, M, N is replaced by A, B, C. The vector equation of the line that passes through 2 points whose position vectors are A and B is given by R is equal to A plus lambda B minus A. Okay, R is equal to A plus lambda B minus A. Next, Cartesian equation of the line that passes through 2 points. So here we are using the relation B minus A. So we need to go on subtracting the coordinates of B and A. See, when we compare the previous equation and the second equation here, in the numerator, whatever the values are there, the same values are repeated here. And L, M, N are replaced by the difference of the point B and point A. That is x2 minus x1, y2 minus y1, and z2 minus z1. So this is the Cartesian form of the plane when it is passing through 2 points. When it is passing through 2 given points. Next, we will discuss some more results regarding lines, related to lines. Next, two lines are said to be coplanar if they lie on the same plane. So two parallel lines are always coplanar. So two non-coplanar lines are coplanar if and only if they intersect. Okay, if and only if they intersect. So two lines are said to be coplanar if they satisfy the condition x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 is equal to 0. And the plane which is consisting these two lines is given by the equation x minus x1, y minus y1, z minus z1, a1 b1 c1 and a2 b2 c2. a1 b1 c1 and a2 b2 c2 here, and they are the direction ratios of the two lines. Next, the plane ax plus by plus cz plus d equal to 0 and the line are parallel if and only if they satisfy the condition a dash plus b dash plus c dash is equal to 0. Are perpendicular if and only if a upon a dash, b upon b dash is equal to c upon c dash. Next, the line x minus x1 upon a dash, y minus y1 upon b dash, and z minus z1 upon c dash lies on the plane ax plus by plus cz plus d equal to 0 if and only if a dash plus b dash plus c dash is equal to 0 and a1x plus b1y cz1 plus d equal to 0. So if they are satisfying these two conditions, then the line will lie on the plane. The line will lie on the plane. Next, equation of the plane containing the line x minus x1 upon a and passing through the point x2, y2, z2 is given by the determinant of, okay, it is given by the determinant of, it is given by the determinant of x, it is given by the determinant value of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, a, b, c. Okay, so the determinant of these equal to 0, we get the equation of the plane containing the line. Next, equation of the plane containing the line is either of the form ax minus x1 plus by minus y1 plus cz minus z1 equal to 0, where they need to satisfy the condition a1 plus bb1 plus cc1 equal to 0. Next, the angle between two lines is given by cos theta is equal to a1 a2 b1 b2 plus c1 c2 divided by mod of divided by square root of a1 square b1 square c1 square a2 square b2 square and c2 square. Next, if they are parallel, again the direction ratios will be proportional. If they are perpendicular, they will satisfy the condition a1 a2 plus b1 b2 plus c1 c2 equal to 0. Next, the angle between the plane ax plus by plus cz plus d equal to 0 and the line is given by sin theta is equal to aa1 plus bb1 plus cc1 divided by root of a1 square plus b1 square plus c1 square into square root of a square plus b square plus c square. So two non-parallel lines which do not intersect are called as skew lines. The shortest distance between these two skew lines is length PQ of the common perpendicular to both of these skew lines. So the shortest distance formula for two skew lines is r is equal to a plus lambda into alpha, or r is equal to b plus lambda beta is given by b minus a dot alpha cross beta divided by mod of alpha cross beta. Okay, so this is the formula to calculate the shortest distance between two planes. Okay, shortest distance between two planes. Okay, two lines, sorry, shortest distance between two lines. So the same formula d is equal to, we can write in Cartesian form as x2 minus x1, y2 minus y1, z2 minus z1 divided by a1 b1 c1 a2 B2 C2 divided by square root of summation of B1 C2 minus C1 B2 whole square. Okay, so this is the formula when it is given in a Cartesian. So we will be discussing a few examples based on this synopsis. So the first question is the perimeter of the triangle formed by the points 1, 0, 0, 0, 1, 0 and 0, 0, 1 is. Okay, so we need to calculate the perimeter of the triangle ABC, the perimeter of the triangle ABC, and the vertices of ABC, triangle ABC are given to us. So this is vertex A, B and C. 1, 0, 0, 0, 1 and 0, and C is 0, 0 and 1. So on simplifying, we get AB. The distance AB will be equal to square root of, so subtract 1 minus 0. So 1 minus 0 will be 1. Okay, 1 square it will be 1 plus 0 plus 0, which will be equal to root 1. Similarly, BC. Okay, similarly, the coordinates, the distance between BC will be again equal to, it will be equal to, see 1 minute, here we have done a mistake. This is 1. Okay, so it will be root 2. Okay, in first case it will be root 2. Next BC, it will be 0 minus 0 is 0. 1 minus 0 is 1, again 1. So again it will be equal to root 2. Similarly, CA, if you simplify, again you will be getting it as root 2. So when you add all the three values, the option, okay, option 3 root 2 will be the right option. So the perimeter, it is sum of three sides. So AB plus BC plus CA will be equal to 3 root 2. So the option 3 is the right option. Okay, option 3 gives us the right answer. So just we need to make use of the distance formula, substitute the terms and simplify. So the next question is the points minus 2, 3, 5, 1, 2, 3, 7, 0, minus 1 form of collinear points, an isosceles triangle, a right angle triangle, and equilateral triangle. Okay, so if we need to check the triangles, we need to calculate the distance formula, and if we need to check whether the points are collinear, we need to make use of the formula. We need to make use of the formula, that is, we need to just write down the determinant value of the vertices. So the determinant value will be minus 2, 3, 5. Next it will be 1, 2, 3 and 7, 0, minus 1. So if we expand this, we get, on expanding the determinant value, we get minus 2 into minus 2 into minus 2 minus 0 minus 3 into minus 3 into minus 1 minus 21 plus 5 into, okay, plus 5 into, it will be 0 minus 14, 0 minus 14. So on simplifying, we get minus 4. See, minus 22 into 3, it will be equal to plus 66. Plus 66. This will be plus 4 plus 66, and then 5 into minus 14. 5 into minus 14, it will be equal to minus 70. So on simplifying this, 4 plus 60 is 70. 70 minus 70, it will be equal to 0. So see, the determinant value of the 3 points is equal to 0. So the points are collinear. So the option 1, collinear points, will be the right option. Collinear points will be the right option. Will be the right option. So just we need to make use of the determinant value and simplify it. So if the determinant value is equal to 0, if it is equal to 0, then we say it is collinear. So 3 points are collinear. Next question, if the extremities of a diagonal of a square are 1, -2, 3 and 2, -3, 5, then the length of its side is √6, √2, √3 and √5 and √7. Okay, so here a square is given. Okay, a square is given to us, so we need to calculate using the square. So say a square is given to us and the end points of a diagonal are given. Okay, so end points of the diagonal A and C I'll consider. So A point 1, -2, 3 is given, and C point 2, -3 and 5 is given to us. So we need to calculate the distance. We need to calculate the distance D. Okay, so if the extremities of a diagonal of a square are, then the length of its side is, so D is the length of the diagonal and S is the length of the side. So there is a direct relation between side and length of the diagonal, √2. So this distance of the diagonal, that is the length of the diagonal, is given by distance formula. So using the distance formula, we can simplify this as, we can simplify it as 2 - 1 is 1, 1 square is 1. Next, -3 and -2. -3, minus of -2 plus 2. So again it will be -1 square, which is equal to 1. And 5 - 3, it is 2 square is 4, whole divided by √2. Okay, whole divided by √2. So on simplifying, we get √6 upon √2, or √6 can be written as √3 into √2. √2 will cancel off. So the answer will be equal to √3. So the option 2 is the right option. So here we need to remember the formula, the relation between the length of the square, side of a square, is equal to length of the diagonal upon √2. So using this relation, we can calculate the side of the given square. Next question, the point P is on the y-axis. If P is equidistant from 1, 2, 3 and 2, 3, 4, then Py is equal to, okay, y coordinate of the point P is equal to, okay. So since the points are equidistant from the given point P, the distance between the point A, this point A, and point B will be same. So applying the distance formula, we get, applying the distance formula here, we get PA is equal to PB. PA is equal to PB. So using the distance formula, I'll consider the coordinates of P. Coordinates of P as x, y, and z. I'll consider it as x, y, z. And the point P is lying on x-axis. So since the point P is lying on x-axis, its coordinate will be its coordinate is lying on y-axis. So its coordinate will be 0, y, 0. Okay, they will be 0, y, 0. Okay, 0, y, 0. So this will be the coordinates of the point P. So using these coordinates and simplifying, we get PA is equal to PB. So first we will be calculating PA using the formula, distance formula. So square root of, so say PA will be equal to 0 - 1, it will be 1 square, and then the second term will be y - 2. Okay, y - 2 whole square, y - 2 whole square, plus y - 2 whole square, plus we get 3 square is 9, which will be equal to root of, it will be equal to say 0 minus 2, it will be minus 2 square, it will be 4. Next y minus 3, y minus 3 whole square plus 4 square is 16. So squaring on both the sides, we get 1 plus 9, which is equal to 1 plus 9, which is equal to 10. 10 plus y square minus 4y plus 4 is equal to 20 plus y square minus 6y plus 9. So on simplifying y square will cancel off. 14 minus 4y plus 6y is equal to 14. See, 14 minus 14 plus 29. So minus 14 plus 29 is 15, and this is 2y. Y will be equal to 15 upon root 2. Okay, so the y coordinate is 15 upon root 2. So the option 1 gives us the right answer. So here we are applying the distance formula. We are calculating the value of PA and equating it with PB, because the point P is equidistant from the given points. Next question. The first point of trisection of the segment joining 3, minus 1, 2 and 9, 5, 2 is 5, 1, 5, 5, 1, 2, 5, 1, 4 and 4, 1, 6. So here we are considering a straight line. Okay, we are considering a straight line, and this straight line is trisected. The straight line is trisected. So this will be the point A, and this is the point B. So this line is getting trisected, that is divided into 3 equal parts. They are asking us to calculate the coordinates of the first point of trisection. Suppose P and Q are the points of trisection. So they are asking us the coordinates of P. So the point P is dividing AB in the ratio 2:1. It is dividing AB in the ratio 2:1. So by using the section formula for the given points, 3 minus 1 and 2, and here the point B is 9, 5 and 2. So applying the section formula, we can calculate the coordinates of the point P. Okay, we can calculate the coordinates of point P. So P x comma y comma z will be equal to, so apply the distance formula. So it will be 1 into 9, it is 9 plus 6, and 2 plus 1, it is equal to 3. Next it will be 1 into 5, and 2 into minus 1 is minus 2 upon 3, and then 1 into 2, minus 4 upon 3, plus 4 upon 3. So on simplifying it further, we get 9 plus 6, it is 15, 15 upon 3, it is 5, 5 minus 2 is 3, 3 upon 3 is 1, and then 6 upon 3, it is 2. So 5, 1, 2 is the coordinates of the point P, So the option 2 is the right option. Option 2 gives us the right option. So the next question is the ratio in which XY plane divides the line segment joining 2, 4, 5 and 3, 5 minus 4 is 5:4, 2:1, 1:3 and 3:2. So we need to calculate the ratio in which XY plane divides the segment. So there is a direct result here. XY plane, okay, XY plane, the XY plane, okay, divides the line, always it divides the line joining 2 points in the ratio minus Z1 is to Z2. Okay, so this Z1 and Z2 are the coordinates of the point A and the point B. Suppose If this is the point A on the line, point B on the line, then Z1 minus Z2. Okay, so see the Z1 value is 5, so it will be 5 is 2. Okay, Z2 value is 4 minus 4, so minus 4, and on simplifying we get 5 is to 4. So 5 is to 4, option 1 is the right option. So here we are making use of this result. Similarly, using this result, if we have YZ plane, so YZ plane, it divides a line joining AB, okay, in the ratio minus x1 is to x2, and similarly xz plane, xz plane, xz plane. So xz plane again it divides AB in the ratio minus y1 is to y2. So this is a note point. You need to remember this. Directly you can write down the ratio, no need of calculating, or you can make use of section formula and simplify. You will get the answer. Okay, so 5 is to 4 is the right option. So the next question, if 2, 3, 4 is the centroid of the tetrahedron for which 2, 3, minus 1, 3, 0, minus 2, minus 1, 4, 3 are 3 vertices, then the fourth vertex is, okay, so then the fourth vertex is, so 3 vertices of the tetrahedron are given. We need to calculate the fourth vertex. Okay, so we have a direct formula for centroid G of a tetrahedron, and centroid G x1, x1, y1, z1 is given by the formula x1 plus x2 plus x3 plus x4 upon 4, okay, upon 4. Next, similarly y1 plus y2 plus y3 plus y4 upon 4, and similarly for the z coordinate, okay, z1 plus z2 plus z3 upon 4. So using this formula, see already the value of G is given to us. It is equal to 2, 3, 4. It is equal to through 2, 3 and 4. Next, see one coordinate is missing. Out of the 4 coordinates in X, one coordinate is missing. I'll consider it as X, Y, Z. So the missing coordinate, I'll consider it as X, Y, Z. So on simplifying, we get 2 plus 3 minus 1 plus x upon 4. Next, second, add the y coordinates, 0 plus 4 plus 3, okay, plus y upon 4, and for the last coordinate we have minus 1 minus 2 plus 3 plus z upon 4. So when we equate and simplify, see 2 plus 3 is 4, 4 minus 1, 5 minus 1 is 4. So it will be, see 2 will be equal to 4 plus x upon 4. Similarly, equate y coordinate. So for y coordinate, it will be 3 equal to y plus 7 upon 4. And for the z coordinate, it will be equal to, see 4 is equal to plus 3 minus 3, it will be 0, so z upon 4. So on simplifying, we get x is equal to 8 minus 4, which is equal to 4. Y is equal to minus, so it will be 4 3 is 12, and 12 minus 7, it will be equal to 5, and z will be equal to 16. Okay, so the coordinates are 4, 5 and 16. So 4, 5 and 16 are the coordinates of the missing vertex. Option 1 is the right option. Option 1 is the right option. Next question. So a line AB in three-dimensional space makes angle 45, 120 with the positive x-axis and positive y-axis respectively. If AB makes an angle theta with positive z-axis, then theta is equal to so say out of the two angles, out of three, two angles are already given, and we know the relation which is connecting alpha, beta, and gamma. Okay, that is the direction ratios. We know the relation L square plus m square plus n square is equal to n square is equal to 1, and we know the value of L. Value of L will be equal to cos square alpha. It will be cos square alpha plus cos square beta plus cos square gamma. Instead of gamma they have given theta, so theta is equal to 1. Okay, so next on simplifying, see alpha value there it is given, it is cos square 45 plus cos square 120 plus cos square theta is equal to 1. Next on further simplifying, see cos square for cos 45 we know it is 1 upon root 2, so it will be 1 upon root 2 whole square plus cos 120, it can be written as cos of 180 minus 60 whole square, 180 minus 60 whole square plus cos square theta is equal to 1. Next on simplifying we get 1 upon 2, and see cos of 180 minus 60, it will be minus cos 60. Minus cos 60 value is minus 1 by 2, so minus 1 by 2 square plus cos square theta plus 1, or this will be 1 by 2 plus 1 by 4 plus cos square theta is equal to 1, or cos square theta is equal to 1 minus 1 by 2 plus 1 by 4 is 3 by 4, or cos square theta is equal to 1 by 4, or cos theta is equal to 1 by 2, or cos theta is equal to 1 by 2 for 60 degree. So the option 3, okay, option 3 gives us the right option. So to solve this example, we have made use of this result. Okay, the result which is connecting the direction cosines L square plus m square plus n square is equal to 1. Then substituting the value of alpha and beta, we can calculate the value of the missing angle, that is theta. The next question is the angle between the diagonals of a parallelogram formed by the points A, B, C, and D. So here the point A is 1, 2, 3, point B, point C, and point D. Okay, so we need to calculate the angle between the diagonals. So first what we will do here is to calculate the angle between the two diagonals of the parallelogram. Okay, so these are the two diagonals A, B, C, and D. So to calculate the angle between these two diagonals, first we will calculate the direction ratios of both the diagonals, and that is direction ratio of AB. Direction ratio of AB will be equal to, subtract A and C coordinate, simplify. What do you get? See, it will be 2 minus 1, which is 1. Okay, next 3 minus 2, which is again 1, and 2 minus 3, which is minus 1. Similarly, on simplifying it further, we can get the direction ratios of, okay, so the direction ratios of BD, subtract B minus D. So on simplifying the coordinates, we get 5, 9, and 7. Okay, so when you want to calculate the direction ratios, we need to subtract C, x2 minus x1, y2 minus y1, and z2 minus z1. So this formula we have to apply. So we have got the coordinates of both the diagonals. Next, we can calculate the angle. We can calculate the angle by using the formula cos theta is equal to. So when we know the direction ratios of two lines, cos theta will be equal to a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square b1 square c1 square into root of a2 square b2 square and c2 square. So substituting the terms, we get cos theta is equal to, go on multiplying, 1 into 5 is 5, 1 into 9 is 9 minus 7 all divided by, take the square root of this, that is the modulus value. So on simplifying, 1 square plus 1 square plus 1 square, it will be root 3, and 5 square plus 9 square plus 7 square. Okay, 5 square plus 9 square plus 7 square, it will be equal to root 155. Root 155. On simplifying, 5 plus 9 is 14. 14 minus 7 is 7 divided by 7 divided by root 3 into 455. It will be equal to 465. Or theta will be equal to, say, cos inverse of 7 upon root 465. Root 465. So out of the given option, third option is the right option. Option 3 gives us the solution by using the formula a1 a2 b1 b2 c1 c2 root of a1 square b1 square c1 square into square root of a2 square b2 square and c2 square. Next question. If the line joining the points, I'll consider this as A and the point B, okay, is perpendicular to the line joining x minus 2, 4, 1, 2, 3, then x is equal to. So they have given the line joining AB and the line joining CD are perpendicular to each other. The line joining AB and the line joining CD are perpendicular to each other. So we need to make use of the condition for perpendicularity of two lines, and that is cos theta is equal to. So when two lines are perpendicular, then a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So this is present for perpendicular lines. Which lines? Perpendicular lines. So first we need to calculate the direction ratios of AB. So the direction ratios of these 2 points will be, on simplifying, we get, just go on subtracting the coordinates, we get 3 minus 3 and 1. Okay, and similarly direction ratios of CD, okay, of the point CD will be equal to, of the point CD will be equal to x minus 1 minus 4 and 1. Okay, x minus 1 minus 4 and 1. So now using the given condition, a1 a2, so it will be 3 into x minus 1 plus minus 3 into minus 4 and then 1 into 1, which is equal to 0. So on further simplifying, we get, so 3x minus 3, okay, plus 12 plus 1 equal to 0. So this will be 3x plus 10 equal to 0. And 3x is equal to minus 10, or x is equal to minus 10 by 3. So out of the given option, option 4 is the right option. Option 4 is the right option. So the next question is the Cartesian equation of the line is x minus 5 upon 3, y plus 4 upon 7, z minus 6 upon 2. Its vector form is, so we know the vector form. Okay, the vector form is r is equal to a plus lambda b. R is equal to a plus lambda b. So using this formula, we can write it as, okay, r is equal to the value of a. See, the point a will be, we need to take the reverse value, that is multiply by minus, and write down the values of a. So minus of minus, it will be plus 5, minus 4, and plus 6. So the value will be, the value of r will be 5i minus 4j plus 6k. Okay, plus 6k in plus lambda into the coordinates are 3 I cap 7 j cap plus 2 k cap. Okay, plus 2 k cap. So out of the given option, okay, option 2 is the right option. Option 2 gives us the right option. Next question. So the next question is the lines x minus 1 upon a, y minus 2 upon 3, z minus 3 upon 4, and the line x minus 2 upon 3, y minus 3 upon 4 equal to z minus 4 upon 5 are coplanar, then a equal to. So we know the condition for coplanar, the determinant value of x2 minus x1, x2 minus x1, y2 minus y1, x2 minus x1, then we have y2 minus y1, z2 minus z1 upon a1, b1, c1, the direction ratios, a2, b2, c2 is equal to 0. So here we need to simplify it. On simplifying, we get, so okay, so first calculate the difference. First calculate the difference between the 2 points. Okay, difference between the 2 points. To calculate the difference between 2 points, okay, what we are doing here is, okay, x2 minus x1. So take the signs as positive and just subtract. So it will be 2 minus 1, which is equal to 1. Next, 3 minus 2, again 1, and 4 minus 3 is also equal to 1. So these are the values of x2 minus x1. Okay, x2 minus x1. Okay, next, write down the values of a1. It is a, 3, and 4, and next point is 3, 4, and 5. Make use of the expansion of determinant. So expanding using determinant, we get 1 into 15 minus 16 minus 1 into 5a minus 12 and plus 1 into 4a minus 9. Okay, 4a minus 9. So on simplifying it further, we get, so this complete value is equal to 0. So on simplifying this, we get minus 1 minus 5a plus 12 plus 4a minus 9. 4a minus 9 equal to 0. So on simplifying, we get minus a plus 2 equal to 0. Or the answer will be a equal to 2. Okay, so a equal to 2. Option 2 is the right option. Option 2 is the right option. The next question is the point of intersection of the line and the planes. So 3 equations are given. Equation 1, that is line, and 2 planes are given, is. Okay, So when such type of questions are given, a point of intersection, so directly you can make use of these values. Out of 4, any one will satisfy the equation. So I will consider the equation. Third equation is simple. X plus 2y plus 3z equal to 0. So if we substitute the first point, see it is addition, it will not be equal to 0. So next what I will do is I will be substituting the second point. I'll be substituting the second point. So when we substitute the second point, what do we get? See, x value is -9, x value is -9. 2 into 6, it is 12, and for 3 into 1, okay, so 3 into 1, it will be 3. So again, it is not equal to 0. It is not equal to 0. Next, we need to go for the next point. So when we substitute the next point, what do we get? See, x value is 9. Okay, 2 into -6, it will be -12. And then 3 into 1 is 3. So on simplifying, we have got 12 minus 12, which is equal to 0. So which is very true for only the option 3. That is 9 minus 6 and 1. So option 3 is the right option. Option 3 is the right option. The next question is the shortest distance between the lines. So 2 lines are given. We need to calculate the shortest distance. So to calculate the shortest distance between the 2 lines, the formula is d equal to the shortest distance. D is equal to b1 cross b2 dot a2 minus a1 divided by mod of b1 cross b2. Okay, mod of b1 cross b2. So using this formula, we can simplify. So first we require the values of b1, a1, a2 at least, and we will get directly. So a2 minus a1, okay, a2 minus a1, I'll write it here, a2 minus a1, okay. So a2 minus a1 is equal to a2 minus a1, the shortest distance between the points. a2 minus a1 is equal to okay, so a2 minus a1, coordinates of the point minus the coordinates, okay. And see here actually this is in vector form. Whatever the formula we have considered in vector form, we can directly make use of the formula in Cartesian form. So the direct formula for applying the Cartesian form is equal to, okay, is equal to, I'll use the formula directly. So d equal to mod of determinant of x2 minus x1, y2 minus y1, and z2 minus z1 divided by, okay, second is a1 b1 c1 and a2 b2 c2, all divided by square root of summation of b1 c2 minus c1 b2 whole square. Okay, so this is the formula. So in this formula we require x2 minus x1. So first I'll calculate the determinant value. So to calculate the determinant value, we have determinant value, apply the same. Okay, x2 minus x1, it will be equal to -1. Next again -1 and -1. These are 3, 4 and 5, and then 2, 3 and 4. Okay, 2, 3 and 4. So when you expand and simplify this, plus minus plus, okay, minus plus minus plus, okay, plus minus plus, okay. So on simplifying it further, we get -1 into 16 minus 15, okay, plus 1 into 12 minus 10 and minus 1 into 9 minus 8. So on simplifying it further, we get minus 1 plus 2 minus 1, which is equal to 0. So out of the given options, so if the numerator is 0, then 0 upon anything will be again 0. So the correct option is the option 4. Okay, so option 4 gives us the right option. So the next question is the distance of the point 2, 3, minus 5 from the plane. Okay, 2, 3, minus 5 from the plane is. So we know the direct formula, distance between point and a plane is nothing but ax1 plus by1 plus cz1 plus d divided by mod of a square plus b square plus c square. Okay, a square plus b square plus c square. So the distance between the point and the plane is given by d is equal to, okay, the distance between point and the plane is given by d is equal to mod of, okay, mod of, so it will be x, x, see in place of x we have 2, so it will be 2 plus, okay, 2 plus 2 into 3, it is again 6, 2 into 3, it is again 6, okay, plus where there is z you have to replace it by, okay, so it will be equal to 10, it will be equal to 10 whole divided by, okay, whole divided by square root of all these, so square root will be 1 plus 4 plus 4, okay, and on simplifying after substituting the formula we get 18, okay, 18 upon 3, 18 upon 3, okay, or on simplifying 18 upon 3, or on simplifying 18 upon 3, and this we have skipped it here, and that is minus 9, and the distance we have not considered, minus 9, okay, minus 9, so this will be 9 upon 3, which is equal to 3, and the option B is the right option. Okay, option B is the right option. The next question, the shortest distance between the lines. So here we are directly making use of the formula d equal to d is equal to mod of b1 b2 b1 cross b2 into a2 minus a1 divided by mod of b1 cross b2. Okay, so b1 cross b2. So first we have to calculate one by one a2 minus a1. Okay, so this is the value of a1, this is a1, and this is a2. Okay, this is a2, this is b1, and this is b1, and this is b2. So first I will be calculating a2 minus a1 directly. So a2 minus a1 is equal to minus I plus 3j plus 2k, and then we need to simplify b1 cross b2. So if you apply the determinant value, b1 cross b2 will be equal to 3i cap minus 0j cap plus 3k cap, and the mod of b1 cross b2, mod of b1 cross b2 b2 is equal to, see, 3 plus 3, it is 9, okay, 9, 18, root 18. So root 18 can be written as 3 root 2, okay, 3 root 2. Now on simplifying we get d is equal to, on simplifying we get d is equal to, so we need to multiply minus 1 into 3 is minus 3, okay, minus 3 plus 0 and minus 6, and the denominator we have got it as 3 root 2. So on simplifying we get d is equal to minus 3 minus 6 is minus 9, mod of minus 9 is plus 9, 3 root 2. So 3 ones are 3, 3s are, so it will be equal to 3 root 2. Okay. So the option 3 root 2, 3 upon root 2. The first option is the right option. First option is the right option. Just now we discussed this example. The distance between the point and the plane, distance between point and the plane is given by d is equal to ax1 plus by1 plus cz1 plus d divided by mod of a square plus b square plus c square. Okay, a square plus b square plus c square. So just now we discuss it, and on simplifying we get the answer as d is equal to 3. We have got the answer as d is equal to 3. Okay, so just now we discuss it. So make use of the formula, substitute the points, and simplify. So we get d equal to 3. So next question. So the next question is the sine of the angle between the straight line x minus 2 upon 3, y minus 3 upon 4, and z minus 4 upon 5, and the plane 2x minus 2y plus 5 plus z equal to 5 is. Okay, so here we are using the formula for the angle between the plane and the line, for the angle between the plane and the line, and the formula for angle between the plane and the line is given by, sine theta is equal to, sine theta is equal to, the formula is a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square b2 square and c2 square. Okay, so on simplifying, substituting and simplifying a1 a2 a3, we know a1 b1, so the direction ratios of the plane 2 minus 2 1 will give us a2 b2 c2, and a1 b1 c1 will be 3 4 and 5. Okay, so on simplifying, substituting and simplifying, we get so this will be equal to mod of 3 into 2 plus 4 into minus 2 and plus 5 into 1 all divided by square root of all the direction ratios. 3 square, that is 9 plus 16. Okay, 9 plus 16, 9 plus 16 plus 25, and a root of 2 square is 4, 2 square is 4 plus 1. So on simplifying the numerator, we get 3. This will be root 50, and root 9 again, it is equal to 3. 3 and 3 will cancel, so we can write it as 50 can be written as 25 into 2, or it can be written as 5 root 2. So if we multiply and divide by root 2, it will be root 2 divided by 10, and the option D. Okay, the option D is the right option. So to simplify this example, we are only making use of the formula for distance, for the angle between line and plane, So using the formula for angle between line and plane, we can calculate the value. Next question, the plane which passes through the point -1 0 -6 and perpendicular to the line whose direction ratios are 6 20 -1 also passes through the point. Okay, also passes through the point. So first we need to calculate the equation of the plane which is passing through a point and a perpendicular vector is given. So the Cartesian form of this plane is given by a into x minus x1 plus b into y minus y1 and plus c into z minus z1 is equal to 0. Okay, is equal to 0. So on substituting these values, we get, see, the point is minus 1 0 minus 6, so x1 y1 z1 will take the value minus 1 0 and minus 6, and the direction ratios are 6 x into minus of minus 1, it will be plus 1, b value will be 20, y minus y1 y1 value is 0 plus c value is minus 1 into z minus of minus 6, it is plus 6. So on simplifying, we get the equation 6x plus 6 plus 20y minus z minus 6 is equal to 0, or we get 6x plus 20y minus z equal to 0. Now this is the equation of the plane. Equation 1 is the equation of the plane. We need to simplify and check which of these points is lying on this. So if you substitute the first point, x value is 1, y value is 1, and this is minus 26, it will be equal to 26 plus 26. But when we substitute the second point, see, origin 6 into 0, 20 into 0 and minus 0. So the overall answer will be 0, that is RHS. So the point that is origin 0, 0, 0 lies on the given plane. Okay, lies on the given plane. The next question, the angle between the planes 2x plus y plus z equal to 3 and x minus y plus 2z is equal to 5 is, okay. So we need to calculate the angle between these two planes, these two given planes. So the formula for angle between the two planes is equal to, okay, is equal to cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 plus a1 square plus b1 square plus c1 square into root of a2 square b2 square plus c2 square. Okay, so directly using the formula we will simplify this 2 into 1, so we get 2 into 1 plus 1 into minus 1, multiply the direction ratios, and then 1 into 2, okay, 1 into 2 whole divided by square root of this will be 2 square 4 plus 1 plus 1, and then again we have 1 plus 1 and 4. So on simplifying we get 2 plus 1 minus 1 and plus 2. Okay, so it will be 4 minus 1 which is equal to 3. Okay, and divided by 4 plus 1 plus 1, it is 6, root 6 into root 6, it will be equal to 6, or on simplifying we get 3 upon 6 which is equal to 1 upon 2. Okay, which is equal to 1 upon 2. Next we need to calculate the angle. Cos theta is equal to 1 upon 2. So we know cos 60 is equal to 1 upon 2, or theta will be 60 degree, or theta 60 degree is nothing but pi by 3. So the option 4 will be the right option. Option 4 gives us the right answer. So the next example, the distance between the parallel lines r is equal to 2i plus 3j minus k plus lambda into I cap minus j cap plus 2k cap, and r is equal to minus 3i cap plus 4j cap plus k cap plus mu into I cap minus j cap plus 2k cap is. Okay, so we need to calculate the distance between the two parallel lines. The formula for distance between two parallel lines, d is equal to b into b dot a2 minus a1, b into cross product of a2 minus a1, whole divided by mod of b, whole divided by mod of b, and this is the formula. So first we will be calculating a2 minus a1. So a2 minus a1 will be equal to, so say a2 minus a1, on simplifying we get a2 minus a1 is equal to minus 5i cap minus 6j cap plus 2k cap. Okay, so this will be the value of a2 minus a1, which we are obtaining by subtracting. Value of b is already given. See, these both the values are same. This is the value of the vector b, that is I cap minus j cap plus 2k cap. Okay, so on substituting, also calculate the modulus of b. So mod of b will be equal to mod of b will be equal to 1, 1 plus 1 plus 4, which is equal to root 6. It is equal to root 6. So on substituting the values, we get d into, d into, so d will be equal to, say, b cross a2 minus a1, divided by mod b. So the numerator part, I have calculated it. That is the cross product of a2 minus a1 and b, which is equal to 4i cap, 12j cap, and 4k cap. 4k cap, whole divided by root 6. So on simplifying this further, we have got the mod of this. The mod of this value. We need to calculate the mod of this value. That is mod of the numerator. So modulus value of the numerator will be equal to, root 176. So when you take the squares of this, divided by 6, and on simplifying, we get 2 into root 22 by 3. 2 into root 22 by 3. Here we are writing 176 as root of 8 into 22. 8 into 22, and 6 can be written as root 3 into root 2. Root 3 into root 2. So on finally simplifying, we get 2 into root of 22 by 3. 2 into root of 22 by 3. So the option 1 gives us the correct answer. So these were few examples on 3D, three-dimensional geometry. So we have discussed the entire synopsis and few questions which have occurred in CET, as well as the questions based on the concepts. So practice it once again. So we'll be concluding this 3D chapter here. Thank you.